All right, we're ready to begin our final unit of the class, which is called Analyzing Data. And this is a particularly long unit, and so we will probably take a break in the middle of it to let people get up, stretch, and otherwise not be overwhelmed by the amount of material that we have stuffed into this unit. So let's get right to it. We're going to click here on Analyzing Data. And although we only see 5 procs listed here under the procedures that we'll be covering in this unit, believe me, these procs do quite a bit, and it'll take us a while to get through all of this. And we're going to start off with t-tests. And t-tests are a relatively simple form of statistical analysis, and we're going to start with the easiest of the t-tests. I'm going to scroll down here a little bit, and we're going to start off here with a one sample t-test, and this is going to test whether the sample of writing scores was drawn from a population with a mean of 50. So we're going to use the Proc T-Test. Again, we'll specify our data set, and here we have H0 equals 50, and this is the value that you put in. So whatever mean you want to specify, we selected 50. You could choose any number you wanted. The one thing you need to remember is this is the number 0, not a capital letter O. Okay, so this is H0. Okay, our variable is right, and then we are going to use the run. Now, as before, we come down here to SAS, which I have up and running. Whoops, it looks like I didn't close my Explorer windows yet. I'm going to close off all this stuff. There we go. Okay, so a little more screen space for us to look at here. And I have brought in all of the program that we're going to be using today. So you can type along with me, or you can just watch as we go through all of this stuff. Okay, so here is our Proc T-Test. I'm going to highlight this and click on the running person. And we will see here that, boy, we get lots of output. And here we have the number of observations. Here is the lower confidence interval for the mean. Here is the actual mean. And then here is the upper confidence level for the mean. And then the same setup for the standard deviation. And here's the standard error. And down here is the part that perhaps you're a little more interested in. Here is the t-value and the associated p-value. So from this we would conclude that the mean of the variable right, at least for this sample of data, is statistically significant from 50. Okay, with our mean being 52.775. Alrighty, so there's that. I'm going to come back down here to my editor and look at the next t-test that we're running, and this is a paired t-test, and we're going to test whether or not the mean of write equals the mean of read. Okay, so again, we tell SAS the data set we want to work with. We use the paired statement here, and we separate the two variables with an asterisk. Okay, highlight this, and I'm just going to use the F3 key on my keyboard so I don't have to keep mousing up to do this. I'm going to press F3, and we see that this will run our commands that we have submitted, and here is our output. So we're looking here at the difference in the means being 0.545. Again, here's the lower confidence limit, the upper confidence limit of the mean. Here's the same information for the standard deviation, and so forth. And we see that we have a t-value that is less than 1, so we know right away that this difference is not statistically significant. Alrighty, what happens if we happen to have a two-sample that are independent of one another? Well, then you do a two-sample t-test, and we can do this both for equal and unequal variances. So I'm going to come back down to my program here. And I'm going to be scrolling down some, and here's the t-test. We are going to do this for the variable female. So we're going to compare the mean of the variable right for the males versus the mean of the variable right for the females. And so the class statement is necessary because it indicates to SAS what is the grouping variable. Okay, so I'm going to highlight all this, and again I'm going to press F3 on my keyboard, and there we go. And voila, we see lots of output. So here's the information when the variable female is 0. Here it is for the variable female when it's equal to 1, and then here is the difference. So here is the mean for the males, the mean for the females, and there's the difference in those means. And so we come down here and we can see that we're given the tests for equal and unequal variances, and both of these are statistically significant. So we conclude that there is a statistically significant difference in this variable for between the men and the women. Now the unequal versus equal variances, which one should you use and when? Well, there are several tests. In fact, we're given one right here, and the problem with a lot of these tests has to do with how normally the variables are distributed, and they're very sensitive to issues of non-normality. So what you can do is the so-called eyeball test. And what you do is you look up here at your standard deviations and you say, are these things relatively close to one another? And basically you're looking at 8 versus 10, which are pretty close to one another, and so I would just go with the equal variances for this one. I don't start thinking that the variances are unequal until we're looking at a difference of, I don't know, 1.5 times the larger versus the smaller. So, you know, if this was like 2 versus 10, okay, those variances probably aren't the same, but 8 and 10, that's pretty much the same thing. Okay, now let's come back down here to our class notes. I'm going to click down here to bring that back up, and the reason I wanted to do this is so that you can see that we have explanation about the output here available on our website. So if you just click here, you will see. Let's do that. We'll click right here. And so if you run over these things with your mouse, it will tell you what each of these things are. And then you can scroll down here, and there's some more explanation of what each of these things are. And you just run your mouse over that. Okay, so we have annotated output. For those who are interested, I'm going to press the back button here so I go back to my web notes, and I'm going to scroll down some. And we're going up to Anova, okay? And as most of you remember from some statistics class somewhere, Anova is basically a t-test with more than 2 categories of the independent variable. Okay, now SAS does have a procedure called Proc Anova, but as it says here in the notes, you can only use this when you have an equal number of observations in each of the cells. In other words, a balanced design. And that is often not what you have. In fact, it's a fairly rare event. So what do? Well, we use Proc GLM instead, and this procedure will work whether or not you have an equal number of observations in the cells. So in other words, it will work either with a balanced or an unbalanced design. And we're going to use Proc GLM to do 3 kinds of analyses. We'll do a one-way ANOVA, a two-way ANOVA, and then we will do an ANCOVA, or analysis of covariance with it, okay? And while we're here, I would like to point out that, again, we have annotated output. So you can click here and see some annotated output to help you understand the various parts of the output that you'll be seeing when you run these procedures. And this is kind of helpful because I know that SAS does produce a lot of output with these procedures, and if you're not used to seeing all of this stuff, well, it can get to be a little bit confusing. Alrighty. That's that. Let's come back down here to our SAS program. And I'm going to click here on Editor to bring up the program. And here's our first GLM. We'll scroll down so we can see the whole thing. And this is going to be our one-way analysis of variance. And we've got some stuff in here that could go for some explaining. First off, we have a class statement. Now we saw this up in Proc T-Test, and it does the same thing here in Proc GLM. What it does is tell SAS that the variables listed on that statement are categorical, and so SAS will treat them as categorical. If they are not listed on the class statement, SAS is just going to assume that they're continuous variables, and obviously that would be problematic. Okay, we have a model statement, and this is the dependent variable equals the independent variable. Okay, that's not too difficult. That makes some sense. We have here a slash, which indicates to SAS that options are coming. And in this case, the only option we have listed is SS3. And what this indicates to SAS is to show us only the sums of squares 3. If you'll remember, there are at least 6 different kinds of sums of squares, different ways of calculating this value, and we're interested only in what is known as sums of squares 3, and so we're just limiting down the output a little bit. We have the run, and then we have a new line here that says quit. And some procedures in SAS are what are known as interactive. And if you don't use the quit statement, you can continue to submit more statements to be run from within that proc. And this allows you to do, say, modifications to a model statement or completely new model statements and run different models and not have to run the whole procedure all over again. So I am just going to show you what this really looks like. I'm just going to highlight this portion. I'll leave off the quit. I'm going to press F3 on my keyboard, and there we go. And click back here to my output so that you can see. And here is our output. So it looks like we have a statistically significant effect of program type on our dependent variable right here. Here is the mean of right. Here are the type 3 sums of squares that we requested. Okay, and because we only had the one variable in the model, of course, these values for the model and for the variable will be identical. Okay, so there's that. This output, pretty easy to get through. Okay, not so bad. Let's come back here to the editor window, and you'll see right up here that it says Proc GLM is running. If we want to get rid of that, just highlight your quit and press F3 or click on your running person, and there it goes away. And so that's how you know that a procedure is interactive or not. And if you have Proc GLM or Proc anything else running, and you move on to another Proc or issue another Proc GLM command, well, it will go ahead and run that. Okay, so there's a couple of ways of terminating that. Let's move on down here a little bit, and this is the two-way analysis of variance that we were talking about before. And so here on our class statement, we have both of our categorical variables, female and prog. And this time we're going to say math equals female prog and their interaction. And you specify an interaction by listing the two variables and then the asterisks in between them. If we had a much larger model and we wanted to do a 3- or 4-way interaction, well, you would just keep doing star variable all the way out. Okay? Again, we're just asking for the sums of squares 3, and so let's highlight all this. And I'm going to press the F3 key on my keyboard, and there are our results. Okay, so we're looking up here at the model, and it looks like the model is statistically significant. We're going to come down here, and we see that the variable female is not statistically significant. The variable prog is in fact statistically significant, and the interaction of these two variables is not. Okay, so that is a brief tour of the analysis of variance stuff. Let's move on now to analysis of covariance. click down here on my editor window to bring it up, and I'm going to scroll down just a smidge. Here's our analysis of covariance, and you can tell that this is ANCOVA because there's an independent variable that is not listed up here on the class statement. And again, if the variable is not listed on the class statement, SAS is going to assume that it is a continuous variable. So there is that. Highlight that. I'm going to press F3 on my keyboard. There we go. Here is our output. Alrighty. Looks like the model is statistically significant. We're going to come down here. Looks like both read and prog are statistically significant as well. Okay, so that is analysis of covariance. Now we're going to go through one more proc before we take our break, and this is going to be Proc Reg. And we've seen this previously. This is how we do regression. I'm going to come down here to my editor window, and I'm going to do some scrolling down here. And again, you'll see right away that Proc Reg is another one of the interactive procs, so we've included a quit statement here. And in this Proc Reg, what we're going to do is have right equal to female and read. Okay, now female is a dichotomous variable, so we don't have to worry about making dummies or anything like that, and read is a continuous variable. I'm going to highlight all of this and press F3. And so here we go. Looks like the model is statistically significant. In here you get the root mean square error here, the mean of the dependent variable, coefficient of variation, your R squared, and your adjusted R squared. Okay, so we look down here, we get our parameter estimates, labels if our variables had any labels. Here are the parameter estimates. Okay, so female, read, here are our t-values, associated p-values, and it looks like both of our variables are statistically significant. Okay, let's come back over here to the class notes for a second. So I'm going to click down here, and I'm going to scroll down here into the regression part of it. And again, we have annotated output for you. So if we click here on annotated output, again, you can see here's the output, and then if you run your cursor over this, you can see what each of these things really is. Okay, so there's that. I'm going to press the back arrow on my browser so I go back to my notes. And we're ready to move on to our next regression model. As you can see here, it's a much larger model, and we have requested some options in our output. Okay, again, the slash indicates that options will follow. And this is the same on the model statement, both in GLM and in Proc Reg. Okay, I'm going to come down here to SAS. I'm going to click on my editor window to bring that up. And I'm going to scroll down just some here. And, oops, looks like we don't have a quit here. I think I'm going to add one in. UIT, there we go. And we will highlight this and press F3. Oh my, look at all this output. I'm going to hit the page up key on my keyboard, see if we can't get up to the beginning of the output. I think it's up a little bit higher than this. Oh goodness, lots and lots of stuff. All right, this looks like the beginning of the output for this. Okay, model is statistically significant. It looks like we're accounting for just over 55% of the variance. Okay, that's looking pretty good. We're going to scroll down here some. Alrighty. Variable female, it looks like it's statistically significant. Type of school, well, that's not. Looks like read, math, and science are all statistically significant. Okay, we're going to scroll down here, and we had requested, let's see here, tolerance and variance inflation factor, and so that's what we receive here. We had requested the standardized estimate. That was the STB option that we had listed, and so those are given here. And I'm not going to go over what all of this output means. Again, we have the annotated output for you, but these are important things, at least the tolerance and variance inflation factor, with regards to determining if the assumptions have been met correctly. Okay, let's scroll down here some more. And here we go. These are the output statistics that we had requested. So when we had the option P there, that gave us the predicted value, and the option R gave us the residuals. Okay, and then all sorts of other diagnostics. Over here we got Cook's D, studentized residuals, standardized residuals. Oh, goodness gracious. So the point here is not to go through all of these and describe what everything means. It's just to show you how you can get these things when you find out that you actually need them. Okay. Now, while we're on the issue of regression diagnostics, you may be wondering, well, how do I make some plots to help me see if everything is meeting these assumptions? For example, you might want to do fitted versus predicted plot or something like that. Well, SAS makes these kinds of things really easy for you. And so I'm going to come down here and click on my editor and scroll down here. And I'm going to make this a little bit larger so you can see the whole thing all at once. And we will go through here and explain all of these statements to you. So we're going to make, looks like 3 plots here and an output data set. Alrighty, we're going to start down here and then we'll get to this stuff up here. Here's the Proc Reg statement. Here is the data set we're working on. We understand that. Here's the model statement. So we're having math as our dependent variable and right and social studies as the independent variable. Okay, not too difficult. Now we get down to here and we have a plot statement. So this is obviously going to create a graph for us. And this R dot star P dot, what is that? Well, this is residuals and the P dot are the predicted values. Okay, and we don't actually have to create these variables. SAS will do it for us, and we let SAS know that R and P are not just variables in our data set by using the period after them. Okay, so we're going to come down here, and this here is going to be a normal probability plot with the residuals, and then here we're going to get a normal quantile plot with the residuals. Okay, so that's what these are, and these here are going to look to see if the residuals are normally distributed. We have an output statement, and this is going to say that we want to create an output data set. We're going to call it temp, so we use the out equals option to create the data set, and in this we want the predicted values, which we called predict. Okay, this is a variable name here. You can name it whatever you want. We said predict, you know, so it would be kind of obvious. R equals, again, SAS keywords, and then a variable name which we called resid because R will give us the residuals. We end with our run and our quit. Okay, back up to the top. What is this stuff? G options reset equals all. What this will do is reset all of the options associated with the graphs, okay? And we do this because SAS will remember the options you've set for graphs that you've made previously in your current SAS session, okay? So if I still had all the stuff from previous units where we had been making the histograms and box plots, if I had used any sort of symbol statements or anything like that, SAS would remember them and try and apply them to my current graphs. Well, that's not really what I want to have happen, so I'm just resetting all of the options back to the defaults. Next, I have a symbol 1 statement, and I'm going to say that I want my symbols to be color blue and their value to be a dot. In other words, I want dots as opposed to the default symbol, which I believe is a little plus sign. Okay, now the other thing is that you'll notice that these things are just kind of hanging out in nowhere land. They're not part of a data step and they're not part of a proc. In general, things are either in a data step or they're in a proc step, but there are some option statements and things like symbol statements that live outside of those two kinds of steps. So although they're relatively rare, especially when you just get going with SAS, that is legitimate, it does occur, and that's what's going on there. Okay, way too much explanation. Let's highlight all this stuff, run it, and just see what we get. So I'm going to press F3. Oh boy, and we see all sorts of stuff flashing by us. Let's come over here to the log window first, and I'm going to make sure that everything worked okay. Scroll up here some. Here's the Proc Reg, 200 observations read and 200 observations used in the computations. Good. SAS changed a graph name or two. That's okay. We don't care about that. And then the data set called work.temp, temporary data set, has been created with 200 observations and 14 variables. Okay, looks like everything went just fine. Let's come over here to the output window and have a peek at the output. So this is the regression that we just ran. The model is statistically significant, and the two variables, writing and social studies, are also statistically significant. There's that. We'll come over here to our graph window. We'll click on that. And so here is our residual versus predicted plot. And we see that the residuals are fairly randomly distributed, which is what we want to see. I'm going to press the page down key on my keyboard. Okay, here is the normal probability plot, and what you want to see are all these points lining up on a straight line on this diagonal here. Okay, and by and large they're pretty well doing that, and when they line up on this diagonal here, this indicates a normal distribution. Okay, so that's why you want to see this. And I'm going to page down one more time, and this is the normal QQ plot, or normal quantile plot. And again, what you're looking for are the residuals to line up on the diagonal here. And we see we have some deviations from normality here at the extremes, and that's actually not uncommon because the quantile plots tend to be a little more sensitive to non-normality out at the extremes, whereas the normal probability plots, they tend to be more sensitive right in the center, and so that's why we tend to use the two in combination. And so that seems to be quite a bit. Let's do one last thing before we take our break. I'm going to come down here to the editor window. I'm going to scroll down some, and we're going to do a Proc Print on that dataset temp that we created, and we're only going to look at the first 20 observations, and we'll look at the variables math, predict, and resid. So I'm going to highlight this, press F3, and there we go. And now we can see the predicted values and then the residuals. Okay. That was quite a bit of stuff. Why don't we take a little break, and we will come back and work on some logistic regression and then some non-parametric statistics.